Elementary group theory. Today we are going to start elementary group theory. It's a very important chapter for class 12, grade 12 mathematics, basic mathematics. Group theory. What is the meaning of group theory? First we go in introduction of group theory. Before group theory, we go in binary operation. What is binary operation? In group theory, we need binary operation. Binary operation we need. Binary operation. First, we can say F from S cross S to S. Second, we can say F from Z plus Z to Z. Third we can say F from N cross N to N. These notations which I have written over here, these notations are the notations of a binary operation. The notation is binary operation ko notation. F from S cross S to S. What is the meaning of this? F from S cross S को meaning चाहिँ F from S cross S to S को meaning चाहिँ कुनै पनि हामीले कुनै फंक्सन सेटमा भएको फंक्सन चाहिँ त्यही सेटसँग अपरेट गर्दाखेरि त्यसको एलिमेन्ट्स चाहिँ त्यही सेटमा बिलोङ गर्नु पर्यो. कुनै पनि फंक्सनमा भएको सेटमा भएको एलिमेन्ट्सलाई त्यही सेटसँग अपरेसन गर्दाखेरि त्यो एलिमेन्ट्स चाहिँ त्यही सेटमा बिलोङ गर्यो भने त्यसलाई के भनिन्छ? दैट इज कॉल्ड बाइनरी अपरेसन अन F. बाइनरी अपरेसन अन F. F मा भएको बाइनरी अपरेसन भयो. S क्रस S टु S मीन्स कुनै पनि सेटको एलिमेन्टलाई त्यही सेटको एलिमेन्टसँग अपरेट गर्यो भने त्यो अपरेट गरेर आएको एलिमेन्ट्स चाहिँ त्यही सेटमा बिलोङ गर्नु पर्यो. त्यसलाई हामी के भन्छौं? बाइनरी अपरेसन on S, which is defined by F. Now next binary operation is F from Z plus Z to Z. F from Z plus Z to Z. Z, what is the meaning of Z? Z means positive integer. Positive integer लाई positive integer में sum गर्यो भने त्यो integer कहाँ पर्छ? That integer belongs to positive integer only. So F from Z plus Z to Z. This is also an example of binary operation. This is also an example of binary operation. And next, F from N cross N to N. N means natural number. N means, what is N? N is natural number. N is natural number. And Z is positive integer. Z is positive integer. And S means S is set. S is any set. Any set containing different elements, that is called set S. कुनै पनि फंक्सनमा दिएको सेटमा त्यही सेटमा भएको एलिमेन्ट्सलाई अपरेट गर्दाखेरि if that elements belong to the same set, then that function is called, that operation is called binary operation. Notations of binary operation. We go in notation of binary operation. Notation of binary operation. We can use the different notation. For example, plus circle, minus circle, cross circle, or not only, not only, or we can use streak. We can use square sign. We can use triangle sign. We can use delta sign, or we can use just point only, etc. These are the notations of binary operations. This notation we use in binary operation. For example, F from N to N, F from N plus N to N is defined as A not B equals to A plus B, where A comma B belongs to N. This is also a binary operation. What I define here, F from N plus N to N. मैले एउटा नेचुरल नम्बर को एउटा यस्तो सेट लिए जुन नेचुरल नम्बर को सेटमा चाहिँ त्यो नेचुरल नम्बरलाई एड गर्यो भने के आउँछ? रिजल्ट चाहिँ नेचुरल नम्बर नै आउँछ. इज डिफाइन्ड एज A not B equals to A plus B. अब यहाँ नट ले के डिफाइन गर्यो त भन्दाखेरि A not B means A plus B. A not B means A plus B, where A comma B belongs to N. A र B कुनै पनि लिन पाइयो. For example, if A equals to 1 and B equals to 2, then it will be 1 not 2 equals to 1 plus 2. 1 plus 2 means 3. 3 belongs to N. 3 belongs to And this is the example of binary operation, including the notation of binary operation. Now we go in question. The first question is, S is given set. Capital S is given set, and A comma B belongs to S. An operation star is defined by A star B. Two questions are here. I'm giving you two questions. First question says that an operation star is defined by A star B equals to A plus B on S. And S is a set. And including in the set S, the elements which are including are -1, 0, 1 is not a binary operation. We need to prove that this operation is not a binary operation. And next question is question number B. A star B equals to A minus B on S, and set S is here. S equals to set of integers is a binary operation. S is set of integer. S means set including all the integers. That means S in second question, B number. Now first we do question number A, solution of A number. Here A comma B belongs to S, and operation is A star B equals to A plus B, and set S, elements of set S are -1, 0, 1. Element of set S are -1, 0, 1. अब हामीले सेट S मा भएको एलिमेन्ट्सहरुलाई यहाँ दिएको फंक्सन अनुसार अपरेट गर्नु पर्यो. यहाँ दिएको बाइनरी अपरेसन अनुसार हामी के गर्छौं, अपरेट गर्छौं. यदि अपरेट गर्दाखेरि यहाँ भएको एलिमेन्ट्सहरुलाई अपरेट गर्दाखेरि यो एलिमेन्ट्सहरु A सेटमा इन्क्लुड भयो भने that operation we can say a binary operation. Otherwise we cannot say that operation is binary operation. यहाँ भएको एलिमेन्ट्सहरुलाई अपरेट गर्दाखेरि एलिमेन्ट्स चाहिँ इन्क्लुड हुनु पर्यो, A सेटमा इन्क्लुड हुनु पर्यो. त्यो भयो भने हामी यो अपरेसनलाई के भन्छौं, we can say the operation is binary operation, otherwise no. Let us consider, we can take any one, or you can directly say that this is not a binary operation. For example, if you take -1 and 0, -1 plus 0 is -1. -1 belongs to this set. If you take 0, 1, 0 plus 1 is 1. 1 belongs to that set. If you take -1, 1, -1 plus 1 is 0. 0 belongs to that set. But if you take -1 and -1, what it will be? We can say A equals to -1 and B equals also -1. -1 and -1 हामीले लियौं भने -1 र -1 कति भयो, -2 भयो. -2 doesn't belong to in this set. That's why this operation is not a binary operation. That things we need to show here. Let us suppose that A equals to -1 and B equals to -1, where A comma B belongs to S. Therefore, A star B equals to A plus B. This means -1 -1 equals to -2. -2 doesn't belong to S. Therefore, star is not a binary operation. हामीले यहाँ बाइनरी अपरेसन प्रुभ नगर्नको लागि चाहिँ कुनै एउटा एक्जाम्पल मात्रै फेल बनाइदियो भने त्यो हामी सो गर्न मिलिहाल्छ. र यदि बाइनरी अपरेसन प्रुभ गर्नुपर्ने थियो भने चाहिँ हामीले प्रत्येक मोर एक्जाम्पल्स we will take and we will write that etc there, so on we can write that. तर एक्जाम्पल हामीले यहाँ के गर्नु छ भने we have to show this operation is not a binary operation. So कुनै एउटा हामीले एक्जाम्पल लिएर त्यसलाई यो एलिमेन्ट्स यो सेटमा इन्क्लुड गर्दैन भनेर प्रुभ गरेपछि हामी के भन्न सक्छौं, star is not a binary operation in question number A. Now we go in question number B. In B number also same thing. A comma B belongs to S. But what is S here? S is set of integers. S means S belongs to set of integers. Operation is A star B equals to A minus B. A comma B belongs to S. Now we take some elements for A and B. Whatever elements you take for A and B, all elements they include in this operation. All elements they include in this operation. For example, you can take set of integers. A equals to 1 and B equals to 1. 1 minus 1, 0. 0 is also integer. Suppose you can say A equals to 2 and B equals to 5. 2 minus 5, minus 3, that is also integer, but that is negative integer. Set of integers means all the integers, all the numbers, including negative and positive both. Set of integers means dot 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 minus 3, minus 2, minus 1, 0, 1, 2, 3 dot dot, all the integers, all the whole numbers, including negative as well. That's why a र b को ठाउँमा जुनै भ्यालु लिए पनि, जुनै इन्टिजर लिए पनि हामी के गर्न सक्छौं, we can show that that integers or that operation, it belongs to this operation. That's why we can say this operation is binary operation. Now we take some example. Let us take some example. I'll do over here. Let us take some examples. Let a equals to 1 and b equals to 5 belongs to S. Therefore, a star b equals to a minus b means 1 minus 5 minus 4 belongs to S. Again, take other values. A equals to 0 and b equals to minus 6 belongs to S. Therefore, a star b equals to a minus b equals to 0 minus b, b is minus 6, so minus 6. This will be 0 plus 6, 6 belongs to S. Therefore, all elements which we take for a and b in that operation, that elements belong to that set itself. So you can say that set of integers is a binary operation. Therefore, for all a comma b belongs to S, a star b equals to a minus b is a binary operation. Now we go in second question. The second question is, let S equals to minus 1 comma 1 and and cross denotes the operation of multiplication. S equals to minus 1 comma 1 and cross denotes the operation of multiplication. Represent it by Calais table. We need to represent this operation by using Calais table. What is the meaning of Calais table? I'll say later. Calais table को meaning के यो म भन्छु. हामीले यो operation लाई Calais table मा represent गर्नु पर्ने. And next question is, so that the multiplication is a binary operation on S. हामीले यो multiplication लाई, यो binary operation, यो multiplication लाई यो चाहिँ binary operation on S. S मा चाहिँ यसले binary operation define गर्छ भनेर show गर्नु पर्ने. S equals to minus 1 comma 1. On set S, there are two elements, that is minus 1 comma 1, and this cross denotes the operation of multiplication. Cross denotes the operation of multiplication. If it would be plus, then plus denotes the operation of addition, minus denotes the operation of subtraction, like that. But here is cross denotes the operation of multiplication. Let us draw a Calais table. Solution. S equals to minus 1 comma 1 and cross denotes the operation of multiplication. The operation of multiplication. Now I'll draw the Calais table. Calais table is two elements are here. On set S, there are two elements, so we need to draw three boxes for two elements. One, two, three. Also 1, 2, 3. 3 by 3 boxes. If there are two elements, then we need to draw 3 by 3 boxes. If there are 3 elements, then we need to draw 4 by 4 boxes. If there are 4 elements, we need to draw 5 by 5 boxes. And here we need to write operation cross and minus 1 and 1. These are two elements on horizontal. I have written the two elements on horizontal box. Another minus 1 and 1. We need to write these elements of set S on horizontal and on vertical as well. That's why. And operation, for operation of multiplication, we need one box. So if there are two elements, you need to draw 3 by 3 boxes, 3 cross 3 boxes. If there are 3 elements, 4 by 4 boxes. If there are 4 elements, 5 by 5 boxes. Now we have to do operation here. We will operate these elements according to our operation of multiplication. Minus 1 into minus 1 is plus 1. Minus 1 into 1 is minus 1. 1 into minus 1 is minus 1. 1 into 1 is 1. Minus 1 र 1 लाई multiplication को operation ले operate गर्दाखेरि सबै एलिमेन्ट्सहरु कहाँ पर्यो त 1 -1 -1 1 यो सबै एलिमेन्ट्स कहाँ पर्यो सेट S मै पर्यो भनेपछि हामीले के भन्न सक्ने भयो भने क्रस डिनोट्स द अपरेसन अफ मल्टिप्लिकेसन व्हिच इज द बाइनरी अपरेसन अन S व्हिच इज बाइनरी अपरेसन अन S बिकज whatever operation we did here all by doing the operation all the elements which occurred in this Callis table all elements they belong to set S that's why this operation is binary operation we can say. Let us write some language. Let A comma B belongs to S and A cross B equals to, we can take any element, for example 1 into -1 equals to -1, other 1 into 1 1, next -1 into -1 is 1, all belongs to S, all belongs to S. Therefore here I'll write the conclusion. By using the operation of multiplication, all the elements which are obtained by cross operation they belong to set S. Therefore S is a binary operation. This is the complete solution of the question. After binary operation, we go in algebraic structure in elementary group theory. In elementary group theory, this algebraic structure, the meaning of algebraic structure and the properties of algebraic structure, it should be known in group theory. Algebraic structure. An algebraic structure is consisting of set G under an operation star on a set G is denoted by G comma star will satisfy one or more of the following characteristics. Algebraic structure भनेको चाहिँ के हो भने algebraic structure भनेको चाहिँ एउटा G comma star it's an algebraic structure. G comma star नै algebraic structure हो. G comma star algebraic structure के को हो त? That is on set G. And what is the operation? Binary operation. Binary operation is star. यो चाहिँ यस्तो algebraic structure हो जुनमा चाहिँ set G र binary operation star consisting छ. तर त्यो कतिखेर algebraic structure हुन सक्छ भने जतिखेर यहाँ दिएको कन्डिसन्सहरु एउटा अथवा एउटा भन्दा बढी satisfy हुन्छ. सबै satisfy भयो भने त भइहाल्यो. नभए पनि एउटा एटलिस्ट एउटा अथवा एउटा भन्दा बढी कन्डिसनहरु satisfy भयो भने त्यसलाई हामी के भन्छौं algebraic structure भन्छौं. An algebraic structure is consisting of set G under an operation star on a set G is denoted by G comma star will satisfy one or more of the following characteristics. Now I'll write characteristics. First characteristics is closure property. Closure property. Closure property, or we can say closure characteristics or closure axiom. Closure property. If A comma B belongs to G, A star B must be belongs to G. If A comma B belongs to G, then A star B must be belongs to G. This is closure property. If A comma B belongs to G, then A star B must belongs to G. A star B belongs to G. It is closure property. Now next one is associative property. Associative property. Associative property. If A comma B comma C belongs to G, then A star B star C equals to A star B star C belongs to G. This is next property. That this property is known as associative property. If A comma B comma C belongs to G, then A star B star C must be equals to A star B star C, and that must belong to G. Set G. Second one is associative property. If A, B, C belongs to J, then A star B star C equals to A star B star C belongs to G. This is called associative property. Third one is commutative property. Commutative property. Commutative property. Third one is commutative property. Commutative property is if A comma B belongs to G, then A star B equals to B star A belongs to G. This property is known as commutative property. And fourth one is existence of identity element. Existence of identity element. Fourth one is existence of identity element. If A belongs to G, then there is an element E belongs to G, such that A star E equals to E star A equals to A. Then E is identity element of set Z. Then E is an identity element of set Z. This property, this characteristics is known as existence of identity element. If A belongs to G, then there is an element E belongs to G. Identity element is denoted by E belongs to G, such that A star E equals to E star A equals to A. A ले E लाई अपरेट गर्दा र E ले A लाई अपरेट गर्दा A नै आउनु पर्यो. A star E equals to E star A equals to A. Then E is an identity element of set Z. Last property, 5 number property, existence of inverse element. Existence of inverse element. Existence of inverse element. Inverse element. Last characteristics or last property, existence of inverse element. If A belongs to G, then there exists A dash belongs to G, such that A star A dash equals to A dash star A equals to E belongs to G. Then A dash is the inverse element. A dash is the inverse element of A. A dash is the inverse element of A. This is the last characteristics. Existence of inverse element. If A belongs to G, then there exists A dash belongs to G, such that A star A dash equals to A dash star A must be equals to E belongs to G. Then A dash is the inverse element of A. अब inverse element निकाल्नको लागि चाहिँ हामीले identity element को help लिनै पर्छ. Before knowing identity element, we cannot find the inverse element in elementary group theory. हामीलाई identity element थाहा नभइकन हामी inverse element निकाल्न सक्दैनौं, किनकि inverse निकाल्न हामीलाई के चाहिन्छ, identity element चाहिन्छ. कुनै पनि एलिमेन्टलाई, कुनै पनि सेट जी को एलिमेन्टलाई त्यसको इन्भर्स सँग अपरेट गर्दाखेरि चाहिँ के आउनु पर्यो, आइडेन्टिटी एलिमेन्ट आउनु पर्यो. E is the identity element of set Z. त्यही भएर कुनै पनि एलिमेन्टलाई त्यसको इन्भर्स सँग अपरेट गर्दा आइडेन्टिटी एलिमेन्ट चाहिने भएको हुनाले हामीले इन्भर्स एलिमेन्ट निकाल्नु भन्दा अगाडि आइडेन्टिटी एलिमेन्ट चाहिँ हामीले निकाल्नु पर्छ. Existence of inverse element says that if A belongs to G, then there exists A dash belongs to G, such that A star A dash equals to A dash star A equals to E belongs to G. Then A dash is the inverse element of A. If these 5 characteristics are satisfied, then we can say that set G comma star is an algebraic structure. Now we go in question. First question is, let G equals to 0, 1, 2. There are 3 elements on set G. Form a composition table for G. Composition table means Calais table. Composition table means Calais table. Form a composition table for G under addition modulo 3. Under addition modulo 3. Here we cannot use only addition or we cannot use only multiplication. We have to use addition modulo 3. Addition modulo 3 भनेको चाहिँ के हो म अहिले यहाँ भन्छु. Find the identity elements and inverse elements of 1 and 2. यो 1 र 2 को हामीले के निकाल्नु पर्ने, आइडेन्टिटी एलिमेन्ट र इन्भर्स एलिमेन्ट अन्डर द एडिसन मोडुलो 3. एडिसन मोडुलो 3 भनेको चाहिँ कस्तो भने, फर एक्जाम्पल एडिसन मोडुलो 3. Addition modulo 3. This means plus 3. Notice this is plus 3. Plus 4 is addition modulo of 4. Plus 5 is addition modulo of 5. And into 3 is multiplication modulo of 3. Into 4 is multiplication modulo of 4. Addition modulo of 3 means, for example, if you add 0 plus 1, it will be 1. 1 plus 2, it will be 3. But 3 you cannot write in addition modulo of 3. 3 3 or more than 3 we need to escape by subtracting. For example, 1 plus 2 will be 3 minus 3 0, and 2 plus 4 2, this will be 4. Now subtract 3 from 4. 4 minus 3 is 1. And another 2 plus 1 is 3. 3 minus 3 is 0. This we need to write. In addition modulo 3 we cannot write the 3 there. 3 लेख्न पाइदैन. 3 अथवा 3 को मल्टिपल कुनै पनि लेख्न पाइदैन. For example, suppose त्यहाँ चाहिँ 2 र 3 छ. 2 plus 3 कति 5. 5 minus 3 2. This we need to write. The 3 र 4 छ. 3 plus 4 कति 7. 7 minus 6 गर्नु पर्यो अब यहाँ चाहिँ. 7 minus 6 is 1. This is called addition modulo 3. This is called addition modulo 3. Now we go the solution of this question. Solution. Here G equals to 0, 1, 2. These 3 elements are given. And composition table for G is addition modulo 3. Let plus 3 denotes the addition modulo of 3. The addition modulo of 3. Now we draw composition table. Composition table means Calais table. Let us draw composition table. Composition table. Composition table means Calais table. Now I'll draw Calais table or composition table. How many elements are here inside G? 3 elements. So you need to draw the box of 4x4. 4x4 box. Let us draw the box of 4x4. 1, 2, 3, 4. 4 boxes. 1, 2, 3, 4. 4x4 boxes. And our operation, our binary operation is plus 3. Plus 3 means modulo 3. Modulo, addition modulo of 3. Now elements we need to write 0, 1, 2. Here also 0, 1, 2. Now we need to do the sum. We need to do the given operation. That is the operation of addition modulo 3. 0 plus 0, 0. In 0, no problem. We cannot write 3 or more than 3 here. 0 plus 1, 1. 0 plus 2 is 2. 1 plus 0 is 1. 1 plus 1 is 2. 1 plus 2 is 3. But here we cannot write 3. 3 ko sato ke lekhne bhane 3 minus 3 is 0. 0 we have to write. Because it is the addition modulo under 3. 2 plus 0, 2 you can write. 2 plus 1, 3. 3 you cannot write. 3 minus 3 is 0. 2 plus 2, 4. 4 you cannot write. 4 minus 3 is 1. This is the composition table under the addition modulo of 3. Now we need to find identity element and inverse element of 1 and 2. First we need to find the identity element of 1. Then only we do for 2. First we need to find the identity element of 1. What is identity element of 1? Let now identity element of 1 के हो त 1 लाई केसँग अपरेट गर्दाखेरि चाहिँ identity element आयो त. What is the identity element? First we need to find identity element. 1 लाई 0 सँग अपरेट गर्दा के आयो? 1 आयो. 1 लाई 0 सँग अपरेट गर्दा 1 आयो. अर्को केलाई 1 लाई 0 सँग अपरेट गर्दा 1 आयो भने 1 को आइडेन्टिटी एलिमेन्ट के रहेछ त 0 रहेछ. 1 लाई अरु केसँग अपरेट गर्दा यहाँ 1 आएको छ. 1 लाई 0 सँग अपरेट गर्दा 1 आएको छ. 1 लाई 1 सँग अपरेट गर्दा 2 आएको छ. 1 लाई 2 सँग अपरेट गर्दा 0 आएको छ भनेपछि 1 लाई केसँग अपरेट गर्दा 1 नै आयो त भन्दाखेरि 1 लाई 0 सँग अपरेट गर्दा 1 नै आयो. त्यही भएर 1 को आइडेन्टिटी एलिमेन्ट चाहिँ कति रहेछ? 0 रहेछ. 0 is the identity element of 1 under the addition modulo of 3. That we need to write here. Now 1 plus 0 equals to 1 and 0 plus 1 equals to also 1 and 0 plus 1 equals to 1. Therefore 0 is the identity element of 1. 0 चाहिँ आइडेन्टिटी एलिमेन्ट अफ 1 हो. 0 चाहिँ आइडेन्टिटी एलिमेन्ट हो 1 को. अब हामीले के निकाल्नु छ? इन्भर्स एलिमेन्ट. अब 1 लाई केसँग अपरेट गर्दाखेरि 0 आयो त. 1 लाई केसँग अपरेट गर्दा 0 आएको छ. 1 लाई 0 सँग अपरेट गर्दा 0 आएको छैन, 1 आएको छ. 1 लाई 1 सँग अपरेट गर्दा 2 आएको छ. 1 लाई 2 सँग अपरेट गर्दा 0 आयो, 1 लाई के सँग अपरेट गर्दा 0 आयो, 1 लाई 2 सँग अपरेट गर्दा 0 आयो। त्यही भएर 2 चाहिँ 1 को इन्भर्स एलिमेन्ट रहेछ। 2 चाहिँ 1 को के रहेछ? इन्भर्स एलिमेन्ट। अगेन 1 plus 2 equals to 0 and 2 plus 1 equals to 0. Therefore 2 is the inverse element of 1. Therefore 2 is the inverse element of 1. Inverse element of 1. For 1, this is the solution for 1. Again we need to do for 2. Again 2 को पनि त्यही हो। 2 लाई के सँग अपरेट गर्दा 2 नै आयो त? 2 लाई कुन एलिमेन्ट सँग अपरेट गर्दा 2 नै आयो भन्दाखेरि 2 लाई 0 सँग अपरेट गर्दा 2 नै आयो। Therefore 0 is the identity element of 2. Identity element of 2. 2 को आइडेन्टिटी एलिमेन्ट चाहिँ 0। 2 लाई के सँग अपरेट गर्दा 0 आएको छ त? यहाँ हेर्नु पर्यो। 2 लाई 1 सँग अपरेट गर्दा 0 आयो। 2 लाई के सँग अपरेट गर्दा 0 आयो? 1 सँग। So 1 is the inverse element of 2. Therefore 1 is the inverse element of 2. This is the complete solution of this question. Now we go in group theory. We go in group definition of group. After algebraic structure, we go in group definition of group. Let G be a non-empty set and star be a binary operation. Star be a binary operation on set G. On set G. Then G comma star under an operation star is called the group. If it satisfies the following properties, the following axioms. The following properties are the following axioms. Let G be a non-empty set and star be a binary operation on set G. Then G comma star under an operation star is called the group if it satisfies the following axioms. यदि यहाँ मैले दिएको यहाँ हामीले दिएको एक्जियम्सहरु सेटिस्फाई गर्यो भने चाहिँ हामी यो जी कमा स्टारलाई के भन्छौं? ग्रुप भन्छौं। त्यतिखेर हामी यसलाई algebraic exam भन्दैनौं, त्यतिखेर हामी यसलाई ग्रुप भन्छौं। Axioms are first axiom G1, we can say it is G1, group 1 axiom. If closure axiom, okay, the name of this axiom is closure axiom. If A comma B belongs to G, then A star B must be belongs to G. If A comma B belongs to G, then A star B belongs to G. This axiom is called closure axiom. G2. Second axiom is associative axiom. Associative axiom. If A comma B comma C belongs to G, then A star B star C equals to A star B star C belongs to G. This is called associative axiom. And G3, existence of identity. Existence of identity axiom. Existence of identity. If A belongs to G, then there exists an element E belongs to G. There exists an element E belongs to G such that A star E equals to E star A equals to A, then E is an identity element. E is an identity element. And last axiom is G4. Existence of inverse. If A belongs to Z, then there exists A dash belongs to Z such that A star A dash equals to A dash star A equals to E. Then A dash is the inverse element of Z. Then A dash belongs to Z is the inverse element of Z. These are the four axioms of groups. If these four axioms satisfy in a binary operation, then we can say that function, that operation is group. Four axiom: closure axiom, associative axiom, existence of identity axiom, and existence of inverse axiom. If any operation satisfies these four axioms, then we can say that operation is a group. Now after group, we go in commutative group, abelian group. Commutative or abelian group. A group G comma star under a binary operation star is called commutative or abelian if A star B equals to B star A belongs to Z for all A comma B belongs to Z. This group is called abelian group. A group G comma star under a binary operation star is called a commutative group, abelian if A star B equals to B star A belongs to Z for all A comma B belongs to Z. यो चाहिँ ग्रुपको छुट्टै टाइप्स हो, ग्रुपमा चाहिँ यो इन्क्लुडिङ हुँदैन। यदि हामीले कुनै पनि ग्रुपलाई कम्युटेटिभ अबेलियन ग्रुप सो गर्नु छ भने चाहिँ यो हामी देखाउँछौँ। यदि सर्ट क्वेसनमा छ भने हामी यति मात्र देखाए पुगिहाल्यो। लङ क्वेसनमा छ भने चाहिँ हामी ग्रुपको चारवटै प्रपर्टी, चारवटै एक्जियम देखाएर इन्क्लुडिङ दिस एक्जियम अल्सो वी नीड टु शो। भनेपछि if we need to show abelian group, if we need to show any operation consist an abelian group, then we have to show all the 5 axioms including the axioms of group and this abelian group. Abelian group भनेको चाहिँ के हो भने A star B equals to B star A belongs to Z. A star B equals to B star A belongs to Z for all A comma B belongs to Z. This the name of this abelian group is also commutative group also we can say. Now we go in question of group. First question is let G equals to 1 comma minus 1 comma I comma minus I and the operation be of multiplication star so that G comma star forms a group. हामीले G comma star भन्ने बाइनरी अपरेसनले चाहिँ ग्रुप फर्म गर्छ भनेर शो गर्नुपर्ने। ग्रुपमा G भन्ने सेटमा दिएको एलिमेन्ट्सहरु चाहिँ के छ भने 1 minus 1 I minus I. I means imaginary unit, I भनेको के हो imaginary unit. I equals to minus 1 all over root and I cross I is I square means minus 1, you know that. I cross I equals to I square minus 1. I equals to under root minus 1. That is imaginary unit. Now solution. First we make the composition table or Calais table. Here we have G equals to elements 1 comma minus 1 comma I comma minus I. To show G comma star forms a group. Let us draw a a composition table. How many elements are here on this set Z? On set Z there are 4 elements. So you need to draw the table of 5 by 5 boxes, 5 by 5. 1, 2, 3, 4, 5. 5 box horizontally. Now vertical also 5. 1, 2, 3, 4, 5. 5 by 5 box we need to draw because 4 elements are there on set Z, and our operation is of multiplication, that is star. Now we need to put the elements on horizontal form and vertical form. 1 minus 1 I minus I. 1 minus 1 I minus I. Now multiply. We have to multiply because the operation be of multiplication. 1 into 1 is 1. 1 into minus 1 minus 1. 1 into I. 1 into minus I minus I. Minus 1 into 1 minus 1. Minus 1 into minus 1 plus 1. Minus 1 into I is minus I. Minus 1 into minus I is plus I. I into 1 is I. I into minus 1 minus I. I into I is I square. I square means minus 1 is there. I into minus I is minus I square, that means 1 plus 1. Minus I into 1 is minus I. Minus I into minus 1 is plus I. Minus I into I is minus I square, that means 1 plus 1. Minus I into minus I is plus I square, that is minus 1. This is the composition table. Now we need to show that this binary operation, it forms a group. First axiom is our closure axiom. For all A comma B belongs to Z, A star B must be belongs to Z, that is 1 comma minus 1 belongs to Z. So 1 star minus 1 equals to what? 1 star minus 1 equals to minus 1, also belongs to Z. Therefore, the closure axiom holds. Closure axiom के गर्छ यहाँ होल्ड गर्छ. 1 star minus 1 minus 1, 1 star minus 1 minus 1, 1 star I, 1 star minus I minus I, 1 अथवा minus 1 star 1 minus 1, जुन एलिमेन्ट्स पनि हामीले यहाँ सबै यहाँ हामीले अपरेसन गरेर देखाइसक्यौं. त्यही भएर जस्ट एउटा मात्र एक्जाम्पल लिए हुन्छ. क्लोजर एक्जियम होल्ड्स. सेकेन्ड एक्जियम इज associative exam. Associative exam. For all A, B, C belongs to Z. For all A, B, C belongs to Z, A star B star C must be equals to A star B star C belongs to Z. That is 1 minus 1 and I belongs to Z. Then 1 star minus 1 star I equals to 1 star minus 1 star I equals to कति आउँछ त 1 star minus 1 भनेको minus 1, 1 into minus 1 minus 1, minus 1 into I minus I, minus 1 into I minus I, minus I into 1 minus I भनेको यो सबै क्याल्कुलेसन गर्दाखेरि हाम्रो कति आयो minus I belongs to G, minus I belongs to G. Therefore associative axiom holds. Therefore the associative axiom holds. Associative axiom holds. Two axioms we have shown here. Now remaining two axioms we need to show: existence of identity, existence of inverse. Now we show in 3 number, third axiom, existence of identity. Existence of identity, that is, if A belongs to Z, then there exists E belongs to Z such that A star E equals to E star A equals to A belongs to Z. ल अब हेरौँ यहाँ 1 ले कुन इलिमेन्टलाई अपरेट गर्दा 1 आएको छ 1 ले 1 लाई अपरेट गर्दा 1 आयो -1 ले केलाई अपरेट गर्दा -1 आयो -1 ले 1 लाई अपरेट गर्दा -1 आयो I ले केलाई अपरेट गर्दा I आयो I ले 1 लाई अपरेट गर्दा I आयो -I ले केलाई अपरेट गर्दा -I आयो -I ले 1 लाई अपरेट गर्दा -I आयो भनेपछि 1 -1 I र -I को identity element चाहिँ के रहेछ 1 रहेछ 1 is the identity element of all these 4 elements which present in set Z. Therefore 1 is the identity element of 1, -1, I, -I. Since 1 cross 1 star 1 equals to 1, 1 -1 star 1 equals to -1, and I star 1 equals to I, and -I star 1 equals to -I. Therefore 1 is the identity element of 1, -1, I, and -I. Now in 4 number we go. Existence of inverse. If A belongs to Z, then there exists A dash belongs to Z, such that A star A dash equals to A dash star A belongs to Z. A star A dash equals to A dash star A equals to E. E belongs to Z. अब आइडेन्टिटी एलिमेन्ट त हामीलाई थाहा भइसक्यो चारवटै एलिमेन्ट्सको आइडेन्टिटी एलिमेन्ट 1 हो आइडेन्टिटी एलिमेन्ट इज 1 इज द आइडेन्टिटी एलिमेन्ट अफ अल 4 एलिमेन्ट्स अब यो चारवटा एलिमेन्ट्सले कुन एलिमेन्टलाई अपरेट गर्दा आइडेन्टिटी एलिमेन्ट आएको छ जस्तै 1 ले केलाई अपरेट गर्दा 1 आयो 1 ले 1 लाई नै अपरेट गर्दा 1 आयो अब -1 ले केलाई अपरेट गर्दा 1 आयो -1 ले -1 लाई अपरेट गर्दा 1 आयो I ले केलाई अपरेट गर्दा 1 आयो I ले -I लाई अपरेट गर्दा 1 आयो अनि -I ले केलाई अपरेट गर्दा 1 आयो -I ले +I लाई अपरेट गर्दा 1 आयो भनेपछि 1 को इन्भर्स एलिमेन्ट चाहिँ 1 नै रहेछ इन्भर्स एलिमेन्ट अफ 1 is 1 we write that. Therefore the inverse element of 1 is 1 since 1 star 1 equals to 1. Therefore the inverse element of -1 is -1 since -1 star -1 equals to 1. Therefore the inverse element of I is -I since I star -I equals to 1. Therefore the inverse element of -I, therefore the inverse element of -I is +I since -I star I equals to 1. भनेपछि 1 को इन्भर्स एलिमेन्ट 1 हो किनकि 1 ले 1 लाई अपरेट गर्दा 1 आयो -1 को इन्भर्स एलिमेन्ट -1 हो -1 ले -1 लाई अपरेट गर्दा 1 आयो I को इन्भर्स एलिमेन्ट -I हो I ले -I लाई अपरेट गर्दा 1 आयो अनि -I को इन्भर्स एलिमेन्ट I हो -I ले I लाई अपरेट गर्दा 1 आयो. These are the inverse elements of all 4 elements. Now all 4 axioms of group are satisfied, so you can say this forms a group. Conclusion we need to write. Therefore here I write conclusion. All the axioms are satisfied by G comma star of group. Therefore G comma star forms a group. This is the complete solution. This is conclusion. Now we go in question number 2 of group. Question number 2 is, so that the set of all positive rational numbers form an abelian group under the composition defined by a naught b equals to a b by 2. We have to show that set of all positive rational numbers. Set of all positive rational number means all the rational numbers, means the number without radical sign. The number without radical sign, and that must be positive as well. Radical sign means root sign. The number without root sign is called rational number. For example, 2, 3, 4, 3 by 4, 5 by 6. Fractional number also are rational number, but that must be without root sign. Positive rational number, prove that the set of all positive rational numbers form an abelian group. We have to show here that set of positive rational numbers form an abelian group, means all 5 properties we have to show. 4 properties of group and 1 additional properties of abelian group under the composition defined by, and the operation is defined as a naught b equals to a into b by 2. A naught b equals to a into b by 2. Now we do the solution of this question. Solution: let q plus denotes the set of all positive rational numbers, all positive rational numbers our composition is defined as a naught b equals to ab by 2. Now first we show that closure axiom. First we show closure property. Closure axiom. Let AB belongs to Q plus, then A star B belongs to Q plus. That is, A star B is A star B. Star here is the given operation is not, so we can use not here, not star. A naught B equals to Q belongs to Q plus. A naught B is AB by 2. A by 2 belongs to Q plus. Therefore, closure property holds. Therefore, closure axiom holds. Now, second axiom, we go in second axiom. Second axiom is associative axiom. Associative axiom. Let ABC belongs to Q plus. Let A comma B comma C belongs to Q plus. Then A naught B naught C equals to A naught B naught C belongs to Q plus. That is, A naught B. A naught B is AB by 2. AB by 2 naught C equals to A naught. B naught C is BC by 2. According to operation, B naught C is BC by 2. That is, AB by 2 naught C is AB by 2 naught C is ABC by 2 into 2 equals to A naught BC by 2 is A naught BC by 2 is ABC by 2 into 2. That means ABC by 4 equals to ABC by 4 belongs to Q plus. ABC by 4 is also a rational number, is also a positive rational number. Therefore, associative axiom holds. Therefore, associative axiom holds. Associative axiom holds. Now we show for existence of identity element 3 number. Existence of identity. Existence of identity. Let E belongs to Q plus be the identity element. Be the identity element. Then A naught E equals to E naught A equals to AE by 2. AE by 2. A naught E equals to E naught A equals to AE by 2. And AE by 2 equals to A. Or AE equals to 2A. A and A are cancelled. Therefore, E equals to 2. 2 belongs to Q plus is the identity element. 2 belongs to Q plus is the identity element. So, Existence of identity property axiom is also holds. Now we go in number 4 axiom, fourth axiom, existence of inverse. Existence of inverse. Let B be the inverse element. B be the inverse element of A belongs to Q plus. Belongs to Q plus. Therefore, A naught B equals to B naught A. A naught B equals to AB by 2 must be equals to 2. A by 2 must be equals to 2 because 2 is the identity element. 2 belongs to Q plus. So here AB equals to 4. Therefore, B equals to 4 by A belongs to Q plus. Therefore, 4 by A is the inverse element of A. Inverse element of A. Now, all properties of groups we have shown here. Now, at last, we need to show for abelian group that we need to show abelian group property. For abelian group, let A comma B belongs to Q plus, then A naught B equals to AB by 2. This means we can say BA by 2. This means we can say B naught A belongs to Q plus, Q plus. Therefore, A naught B equals to B naught A. Therefore, A naught B equals to B naught A belongs to Q plus. So, abelian property of abelian group is also hold, which is abelian group. That is abelian group. Now, conclusion we need to write. Therefore, all the properties, all the axioms of group and the abelian group is also satisfied by the given composition A naught B equals to AB by 2. Therefore, the set of all positive rational numbers forms an abelian group. Therefore, the set of all Q plus forms an abelian group. This is the complete solution of this question.